Hey everyone, in this tutorial we will learn how to generate a standalone ROS node from Simulink's Robotics System Toolbox. For this tutorial you will need Matlab 2016A because earlier version do not have Robotics System Toolbox. So let's launch the Simulink block. Now click on the blank model. This is the Simulink workspace. Now in order to drag and drop the component from the Simulink library, open the Simulink library. We need to find Robotics System Toolbox, which can be used to generate ROS node from the Simulink block. So let's first drag blank messages. These blank messages will be used to generate messages. What will be the message type? Double click on this and double click on the block and choose the message type. For our purpose we are going to choose standard message float 32. Here you go. Sample time will be infinity. Now we will use bus assignment drag and drop. No. Here you can see that data is there, so drag and so shuttle it to the right side, and this one is fake actually, so we need to remove this. Yes. Now now we will create a sign block. So this is a sine wave function. Let's take its amplitude 5 and sample time should be simulation time. So in this way we will not have to use an external signal. Yes. And now from the Robotics System Toolbox drag and drop a publish block. So let's give this topic name sign. And select the message type to be our message type was standard message float, right? We can specify one, or when we are running the ROS code, then we can also then the Simulink will automatically detect what are the topics that are available. You can from the configure network you can specify your ROS master IP address. Let's run the ROS code in the new terminal. Yes. Now you can test the ROS here. So now it's okay. If you will not run the ROS core, let's say I terminated, then this test will fail. Yes, because cannot access the ROS master because it is not running and there is no local host available for this computer. So let's start running again. And also make sure that while generating the C++ code or ROS node in C++ from the Simulink, make sure that you are always running the ROS core in the another terminal. Let's check again. Yeah, press OK. So our Simulink block is ready to generate ROS node. We need to take some of the parameters. So go to the Simulink model configuration parameter. In the solver it should be the fixed step size. Fixed step size is it does not matter for our example, but you can change it to 0.5 0.05 or 0.01. In the hardware implementation, um, select Robotics Operating System Toolbox. Robotics Operating System. Yeah. Here in the maintainer name, you can give your own name and maintainer email address. You can provide the license and version. If you want to redistribute your ROS node, then you must specify a license. Oops. Yes. Now our ROS node is our Simulink block is ready. Let's change the sampling time to infinity. Otherwise, what will happen is that after 10 seconds, the simulation will stop, and this ROS node will stop publishing anything after 10 seconds. So if by providing the infinity, you make sure that you're always publishing on this topic, the sign. So let's save it first. So save it as sign, just sign. That's fine. Now create another ROS node, create another blank model. In this case, in this Simulink model, we will subscribe to the topic that we have created in this sign block, this sign topic. So let's say we have subscribe. So we subscribe to sign. Let's add a terminator. So this will make sure that message is read only when the new messages are available. Now we will use a bus selector. Oops. Let's just expand it a little bit. So message type should be like, what was the message type? Our message type was float 32. Yes. So let's update it first. Update diagram. That's okay, because right now we are not running it, but it should reflect the data. Yes. So these two are not valid, so let's remove this. Select. Okay. So it automatically updated the output port of the bus. So now we have configured our Simulink block so that it can read from the sign topic. Now what we want to do is we want to create a block that will differentiate the sign to produce the cosine. So now let's derivative block. Use this. Let's say constant is 0. Now it will produce the float. It will differentiate the sign, and so what will be the derivative of sine? It should be cosine. So now we will create another blank message. You can also copy or press the control and select them by dragging, and press control and then drag back to the another workspace. You can also just press by select you can also press Ctrl C by selecting these blocks and then press Ctrl V. So in another workspace it will be these similar kind of the blocks will be created, so that you do not have to drag and drop every time. Now let's connect this data to this, and now we will drag and drop another publish block. Let's say its name to be cosine. Its message type should also be float 32. Okay, we are done. Let's make sure that everything is right. Yes. Now in this block also change the model configuration parameter, fix step and hardware implementation to robotics operating system, and like give a maintainer name and email ID. Save this to cosine. Of course we can directly drag and drop a cosine function block from the Simulink library, but this is not our goal. Our goal is to show that we can use a Simulink block to publish some information on the topic, and then another node can subscribe to that topic and differentiate it and then produce a cosine from that information. So now let's generate ROS node. In order to generate the ROS node, you need to press this blue button with arrow pointing towards it. So let's click on this. It will produce some of the files. So okay, expects a signal of data type single, however it is driven by a signal of type double. Okay, so I think we have some kind of mismatch in terms of data types. Let's analyze it. So our input port 2 of the sine bus assignment, input port of, so probably a sine function is producing a precision of the double, but we have specified message type to be float 32, which is of the single precision. Hence, it's the data type mismatch, and that's why we are getting this error. So in order to do that, we need to change the data types from float 32 to float 64. To change the message type, it's also, let's change it. Save, and then let's try generating again. We got the error once again, but this time the compilation error is different because we didn't specify the continuous time for this for the sign in the code generation interface. So we need to fix that. In order to do that, we will have to change the model configuration parameter once again to specify the continuous time for the sign. So let's do that. Code generation. Let's read the error message again. So code generation interface. Okay, this is, you must check this checkbox. Now let's try generating again. Save it. It will probably take a couple of minutes to generate generate the necessary files. You must know that whatever the file will be generated, it will be in the current working directory of the MATLAB. So now we have got a summary report. When this comes, we can know that the generation was successful. Now let's do this for the cosine block as well. But before that, we need to make some of the changes as we did in our sine. So let's select it as 64, because the sine is actually 64 and we have to match with the data types. And we need to also use the continuous time. Let's generate the code for this as well. It will also take a couple of minutes to generate. Here we go. So now let's go to the working directory. So this was the working directory. As you can see, catkin workspace /src. So ls. So you can see that we have some of the new files, like the new file is build ROS model.sh, cosine.slx and sine.slx. Let's save it first, probably that's why it's auto save is there. Yeah. And then cosine.tzz, cosine.ertrtw, these are all the generated files. Now how to generate ROS nodes? So /build second parameter will be the name of the tgz file that has generated files inside it, and the third argument will be the location of the catkin workspace. So our location of the catkin workspace is catkin workspace. We do not have to give the location of the source folder, so let's do that. We are getting error multiple packages found with the same name signed. The reason behind this is that the code has been generated in the same folder where ROS nodes are supposed to be generated, and because of that we are getting conflict. So in order to resolve that, we need to generate these files in some other folder, and from there we need to build the ROS node. So let's change the working directory of the MATLAB where the code will be generated. So let's make the working directory to be the catkin workspace instead of catkin workspace /src, where the new code will be generated. Let's do that again. So I think by this time you must have understood that we cannot have any code, any generated file in the catkin workspace /src folder, because that will have a conflict with the new files that will be generated by the build ROS model.sh shell script. So our cosine block generation is complete. Now let's run the build script. So now we have successfully generated the two ROS node executables. One is the sine underscore node and another one is cosine underscore node. Now let's start running them. So ROS run sine. Okay, we need to source the devel file as well. So source devel setup dot bash. Yep. ROS run sine underscore node. So this has started the ROS node. Now let's see if it is running correctly or not. ROS topic list. So we have ROS topic echo slash sine. So as we can see that the some values are being produced. Now ROS run. Okay, we need to do source as well. Source devel setup dot bash. Yep. So ROS run cosine underscore node. So now let's see ROS topic list. We have ROS topic echo and that's cosine. So some values are being produced in another tab. You can simultaneously see other values like ROS topic echo slash sine. So now you can see that some values are being produced. Now how we will know that whether we have successfully generated sine wave or cosine wave or not? So for that case, let's record in a ROS bag record file. So ROS bag record is a way to capture the data that is being published and subscribed in the real time so that we can analyze them later, or maybe possibly we can plot them in a Matlab using inbuilt functions. Recorded the data in our back file. Now we can use the Matlab to read the back files. So in order to do that, okay, I have already run, so I'm using something from history. Okay, so my back file name is copy dot bag. So now I have some back file. Okay, now I'm going to select the topic sine. Okay, probably name it as back one. Yep, and cosine. Oh, I selected it in the same. Okay. Now we will read data from back select. So we can use the time series function to read. So in this case we have just data. And now let's plot and subplot plot ts1. So let's see how it looks. You can see that it looks like a sine wave. Now let's subplot plot ts2. On the graph you can see that there are two sinusoidal plots. First one is the sine wave and the second one is its derivative, which almost look like a cosine wave, because it somewhat differs from the sine wave in phase by pi by 2. So in this way we can verify our Simulink blocks. Simulink block can not only be used to generate a sine or cosine wave, but we can also write some of the more complex mathematical functions in the Simulink, which can be tedious to write in the standalone C++ code. but the Simulink offers a very elegant and easy way to design complex mathematical blocks. So that's all in this tutorial. If you have any question regarding today's tutorial, please feel free to ask any question in the comments below. Thanks a lot.